Alright, hi guys. In this day 25 questions, they're relatively short questions taken from a relatively recent scholarship paper, which I'd ask you not to look up the marking schedule for. Or even to try and find which particular paper they came from. Okay, so in this first question, what you're asked to do here is to find out when this function is going to be greater than 0, and you're asked to use a number line to do that, and you're also told that x are real numbers. Let's mention that. So basically what you're trying to do here is a bit of a clue, is if you look at when would a fraction be positive. Okay, so there'll be one situation would be when the top and bottom are both positive, and I'll let you think about the other situation when a fraction can be positive. Okay, so that's a bit of a clue, and then what you need to do is consider this particular function and then show on a number line the regions that would make, for example, the top positive and the bottom positive, and then also that other region when this fraction would also be positive, that second situation. So that's enough of a clue. So pause the video here if you haven't already figured this one out. Okay, so coming back and having a look at a solution for this, well, one of the things I noticed about this function was that it does factorize top and bottom, so we can get x minus 2 and x plus 1. Now, when we're going to and also when you look at this bottom quadratic, it also factorizes to x minus 3 and x plus 1. Now what I was going to say was, when you cancel a factor like that, just remember that x being negative 1 will actually make the whole thing undefined, so just be aware of that. Okay, so let's have a look at a number line. Let's get a line, let's make it blue, let's draw it over here, and let's go back to here. So some key points. Okay, so 2 and 3 are going to be key points on this number line. Okay, so let's put, say, 3 here. Let's put 2 here. Okay, so when would the top be positive? Would be when x is greater than 2. Okay, so I'm going to show that like that. You may be wondering about the hollow dot here. Hollow dot means not including. Okay, so we want greater than 2, not equal to 2. And the other part then would also be when x is greater than 3. Now if I look at that, I want both the top and bottom to be positive. Well, that's when both these regions are overlapping. So one answer, I think, is when it's going to be x is greater than 3. Okay, now the other part would be when both top and bottom are negative. Okay, so I'm just going to put that in a different color. Okay, so when x is negative would be when x is x minus 2 is less than 0. X is less than 2, obviously. Okay, and when would x minus 3 be negative? That would be when x is less than 3. Okay, so let's show that as well. Okay, so once again, I want the regions when both are true, when both the top and bottom are both negative. So that would be when x is less than 2. But let's not forget that x cannot equal negative 1. So how would I show that on a number line? Let's go back to that green, -1, let's say here. Okay, so I'm going to show that with a hollow dot there and a hollow dot there. Okay, so basically, if I try and represent the complete set of answers, yeah, x is less than 2, or x is greater than 3, x not equal to -1. Okay, I think that would be a fair enough representation of the answer. Let's double check that. Yes, that's correct. Okay, all right. So that was question 1. Let's move on to question 2. Let's put that on a new sheet. All right, so question 2. Okay, so in this question 2, you're asked to find all solutions for this. The only clue I can really give on this is that I think the logarithms would be quite useful, and also don't always, don't divide both sides by a variable. Okay, so that would be something that you should never do. You should always factorize. So an example of that might be something like, I was trying to think of a simple example. Right, so just pause the video, just trying to think of a simple example. So something like this, for example, is where you might be tempted to just cancel x on both sides, which would be a mistake, because that would remove the solution x equals 0 possibly, unless sine x equal to 3 cos x has a solution of 0, which it doesn't. Okay, but coming back to this then, what you should be doing is to factorize out, maybe bring both sides to one side, make it equal to 0, factorize out x. That would mean that x equals 0 is a solution, and the other solutions would be given by this, whatever that works out to be, which I'm not going to do at the moment. So that's another clue as to something that to be aware of in this question. All right, I'm going to leave you with it now. Think of logs and also be careful about not cancelling a variable. All right, so just pause the video now, okay, if you need to, and then come back to it once you've had a go. All right, so back here, I'm just going to get rid of this. So when I looked at this question here, I thought, well, let's use logs to get these powers down, make it more of a linear type equation. So if we take the natural logs of both sides, or it could be log base 10 if you prefer, and then that should be natural log there, then we can move that power like so. Okay, what I then did was to bring, I'm actually going to write that, am I going to write that as a single power? Now I'll leave it like that for now. I'll bring this to the left, make it equal to 0. Then we can factorize out, well, a few different factors. We can get x, natural log x, as common factors, then root x minus 2 equaling 0. That would mean, therefore, that x is equal to 0 would be one solution. Natural log x equaling 0 would be another solution. That's when x is equal to e to the power of 0, which is 1, or you might know from the graph of the natural log function that it crosses the x-axis at x equals 1. Therefore, that's the solution, natural log of 1 being 0 then. And root x minus 2 equaling 0. Okay, I'll give root x equals 2. Square both sides, you get x equals 4. Okay, now the only thing we need to be careful about here is to always check your solution. So just checking. Okay, if we make x equal to 1, that was silly. Make x equal to 1, so we get 1 to the power of 1 root 1. Does that equal 1 to the power of 2? Okay, well 1 to the power of 1 is equal to basically 1 to the power of 2, which is also 1, so that's fine. What about 0? Okay, 0 to the power of 0 root 0, is that equal to 0 to the power of 2 times 0? But 0 to the power of 0 is undefined. Therefore, x is not equal to 0. The only other solution we've got is 4. So 4 root 4. Is that equal to 4 to the power of 2 times 4? Okay, so that's going to be 4 to the power of, that's 2 there. 4 times 2 is 8. And this is also 4 to the power of 8, so that seems to be fine. So, from that checking, x equals 1 and 4 only. Okay, so that's that one. Alright, just going to pause and we'll have a look at the third one in a second. Alright folks, in this third question then, you're asked to find the equation of the vertical line which halves the area enclosed by this. Now, one thing which I would recommend that you do is actually have a look at the graphs of these two, okay, and then when you sort of look at the area enclosed by that, so I'm just going to pause the video and then bring up what this looks like on Desmos. Right, so here we are in Desmos. Okay, the area enclosed between these two, I'll just do it on top of this for now. Okay, is this area here. Now I'm just going to erase that as well, just for now. Okay, I think it's reasonably obvious that the area, sorry, the line which basically divides the area into two, because you've got some symmetry here. I mean, that wrong thing to grab. This area here, okay, if I change that to a different color, and this area here are equal. So it looks like the x-axis is the line, sorry, the y-axis, sorry, where x equals 0 is the line which cuts the area enclosed into two halves, two equal halves. But how are you going to prove that algebraically, because you won't have Desmos available? So one thing to consider is this idea that if you have an even function is 1. This is not an even function, I'm not talking about this here, but if you have an even function, so let's clear this in Desmos, or hide it. Let's get ourselves an even function. So a very simple even function might be y equals x squared. That's an even squared. That's an even function which is symmetrical around this y-axis here. Okay, so an even function is symmetrical about the y-axis. So that's another clue. Alright, enough clues. Have a go at trying to find out algebraically, or some something other than just looking at the graph that will allow you to conclude that the y-axis, or x equals 0, is that line that we're after. Alright, well, if we have a look now, hope you've paused the video. If you haven't, please do so and then have a go. Okay, so after you've paused the video, let's come back to here. Oh, come on. Oh, go away. Right, okay, so the area between these two curves, okay, will be, okay, well, I don't know what the limits are at the moment, so one thing I'm going to do is perhaps get those limits. Now, I'm not sure if we need to totally do this, but that's a good little algebraic exercise. So I want to find out when that equals to that. Let's bring all terms to one side. Okay, so we're going to get minus x plus x minus 1 is equal to 0. These cancel, get 4x squared minus 2 equals 0. X squared is going to equal a half. X is going to be the positive and negative square root of 1 over root 2. So that will be our limits. And then when you take the top function and take away the bottom function, or the second function, the one underneath, okay, what you end up with is this definite integral. Okay, so you end up with 4x squared minus 2. Now, what you should know from work on parabolas is that this is a parabola that looks something like this. Okay, down there at minus 2. But the point I'm trying to make is that it's an even function. So in other words, this is symmetrical around the y-axis here, so that when you basically calculate this this integral here, you're going to end up with 0 essentially. No, we're not. No, we're not going to end up with 0, but the point is that this area, okay, is symmetrical. That's because this is an even function, that the line that would divide the area into two equal halves, okay, is going to be that y-axis. So what you can say then is that since y equals 4x squared minus 2 is an even function, the line that divides the area into equal halves, I suppose the vertical line, okay, is x equals 0. Okay, and that would be sufficient. Okay, let's move on to the fourth bit. So just pause this video here and we'll move on to the next bit. Alright, so the fourth bit, the last bit of this questions for today, is you're asked to evaluate this definite integral here. Now the only clue I'm going to give you is that a good method for this would be substitution, where you substitute, say, u equal to a part of this function here to make it into something which is more easily integrated. Okay, so if you haven't done anything to do with the substitution method, Can you let me know, please? Because I'm not sure if this was covered last year with the work that you were doing. All right, so pause the video here and have a go and see what you come up with. All right, so welcome back. So when I looked at this, I thought perhaps substitution might be useful. Now I looked initially at substituting let u equal the square root here, which is possible, but then I thought actually a simpler substitution would be to let u just equal to x plus 1. And what we want to do is we want to replace everything involving x with something involving u. We also need to replace the dx with du, and these limits are currently limits for x, so we have to make them limits in terms of u. So let's see what we get if we derive u with respect to x. We just get 1, so du would equal dx if we move this over here. Okay, so what does that give? Well, the other thing is, let's get those limits recalculated. If x is equal to 2, u would equal 3, and if x is equal to 0, then u would equal 1. So let's replace what we can. Oh, one other thing I've got to do here is that if this is true, then x would equal u minus 1. So let's substitute in what we've got. So this limit of x equals 2 would be u equal to 3. X equal to 0 is u equal to 1. The x on top would be u minus 1. And this would be the square root of u, or u to the power of a half. And dx is equal to du. Now that may not look simpler, but it is, because you can split this into 2 bits. So this is u to the power of 1 over u to the power of a half, minus 1 over u to the power of a half, du. That's sort of a line you don't have to put in if you can go straight from here to this next step. So this will be u to the power of a half, if you simplify that, and this will be u to the power of negative a half, du. Right, so with no reason we can't integrate both of these bits now. So we're going to get u to the power of 3 over 2. This will be 2/3 in front then when you integrate. And minus, so this will be u to the power of a half. And it'll be 1 over a half, or 2. So substituting in the first limit, which is 3, okay, then we need to substitute in 1. Okay, so it turns out that this becomes 0, and we end up with so this would be 2/3, so this will be 2/3 minus 2, and if you calculate that, that comes out to positive 4/3. Okay, so that would be the definite integral value. Alright guys, we'll catch you in the next one.